Hey. It's time to get started with Unit 3 notes day 1. Looks like we'll be doing a little elimination, little substitution. It's going to be a good time. You hang in there, right? Mr. Flores will be here with you in just 1 second. Thank you, Matthew. Appreciate that. All right, everybody, let's get to it. As our guest just mentioned, we will be solving systems of equations today by using either elimination or substitution. Now they have given us this system here, and they want us to solve by using elimination. In order to do that, though, you have to have your equation in standard form, which this one currently is. You have your x, you have your y, then it is equal to the constant. Notice this one is not. So you would have to move the y over by subtracting it. I'm going to copy down this top system first. Well, 2x plus 3y equals 12. And now I'm going to subtract y and bring it over there. I'm not going to write it down on paper, but hopefully you know what's going on. Okay, once again, subtracted y, moved it over here to 4x. That now makes it negative. Okay, now we can use elimination. In order to use elimination, you must have either your x's or your y's that have the exact same number, yet opposite symbols. One needs to be positive, one needs to be negative. So if this was only a -3, we could eliminate the y's. I'll tell you what, how about we multiply everything in this bottom row by 3? 3 times 4x, 12x. 3 times -y, -3y, and 3 times 10, 30. Let's see if this is gonna. Okay, now that I've done that, I'm gonna eliminate that middle row. Don't really need it. And I'm gonna combine like terms vertically. Positive 2x, positive 12x. If you combine those, you get 14x. 3y minus 3y, eliminated, gone. That's why it's called elimination. 12, that's positive. 30, that's positive. You combine those, you get 42. And now you can divide both sides by 14. And we see that x equals 3. Now that you know what x is, you can go to either of these systems and use substitution and solve for y. How about I use this system here? So instead of 4 times x, let's do 4 times 3. Why? Because that's what x is, remember? We're going to set that equal to 10 plus y. And now start solving. 4 times 3 is 12. Subtract that 10. 2 equals y. That is our solution. If you were to graph these two equations on an xy coordinate plane, they would meet at the coordinate 3, 2. Whoa, excuse me. It's a good thing I have a cough button on this thing. I was drinking some coffee and it went down the wrong tube. All right, now we're going to solve using substitution. If we take the exact same examples here and we want to use substitution, here's what you need in order to do that. You have to have either an x or a y, that is isolated. Now, 2x, 3y, those aren't isolated because, well, that has a 2 and that has a 3. This 4x is not isolated because it has a 4. This y is almost isolated. It's just y. We just have to move that 10 over here. So I'm going to do that. We would have to subtract both sides by 10. Okay, so you see what I did here? I took that system and I subtracted 10, moved it over there with 4x, and this is now what we currently have. Now let me copy down this top system here. 2x plus 3y is 12. We know what y equals now. Y is 4x minus 10. So what we're going to do is we're going to take what y is, 4x minus 10, and we're going to substitute it for y there. So let me start with 2x plus 3 times, not y anymore. We know what y is. Let's plug this in instead. And now we're going to set that equal to 12. Let's distribute. Okay, I can combine some like terms here. Now add over 30. And divide by 14. X equals 3. Well, that sure looks familiar now, doesn't it? All right. Well, now that we know what X is, we can choose either system and solve for Y. I'm going to use this one. Remember when we isolated Y? We now know that X is 3. So let's take that 3 and substitute it there. And 2 is equal to Y. We already knew that. See, it doesn't matter which system you or what method you use, the elimination or substitution method, as long as you do your math correctly, you're going to get the same answer. And now they want you to solve by graphing. These were the two systems of equations at the top left of your work page. What we have to do is, well, we have to put them in slope-intercept form. Well, I guess, yeah, I'm just going to put it in slope-intercept form. Let me subtract 2x. I'm going to speed up a little bit. We've been doing this for a while now. Let's divide away that 3. And there's one line we can graph. Now let's work on this one. Oh, this one isn't too bad. Let's just subtract 10, bring it over there. So that would give us 4x minus 10 equals y. So these are the two systems that we are going to graph. Let me move this piece of paper. Okay, let me start with the first one that we solved. Y equals negative 2/3 x plus 4. 1, 2, 3, 4. Start at the y-intercept at positive 4. And your slope is down to right 3. Down to right 3. I'm going to stop there. Now, let's graph the second equation. Y equals 4x minus 10. Start at the y-intercept at negative 10. And your slope is 4x, 4 over 1. Up 1, 2, 3, 4, right. Oops, sorry. 1, 2, 4, right 1. Oh, notice that. I'm going to go ahead and stop there. You see where they meet? They meet at the ordered pair 3, 2. Move on to side 2. For example 1, we need to, they want us to use elimination here. We need to eliminate either the x's or the y's. Doesn't matter which one. We just need them to be the same number yet opposite signs. One positive, one negative. Look at the x's. They're both 3. We just need one of them to be negative. So how about we multiply the top system by negative 1. I'm going to multiply everything up here by negative 1. That would give us negative 3x plus 2y equals negative 13. And now I'm going to copy down the bottom system. Okay, let's combine vertically. Negative 3x plus 3x, gone. Positive 2y, positive 4y, that's positive 6y. Negative 13 combined with negative 17, that's negative 30. Divide away that 6. y equals -5. Now that we know what y is, we can choose any system we want and substitute. I'm going to use the bottom system here. 3 times x plus 4 times y, but we know what y is. It's -5. And now begin solving. X equals 1, y equals -5, and as an ordered pair, 1 comma -5. We have one solution to this system of equations. That is the solution. I'm going to be honest with you, folks. I don't have as much time today to record a video, so I'm skipping example 2. I'm going to skip example 4, and I'm also going to skip example 6. We're going to do the odds on this page only. They want us to use substitution for example 3. In order to do that, you must have a variable that is isolated. And my goodness, we do. How kind of them. Look at x, all by itself. So now that we know what x is, we're going to take what it is, and we're going to substitute it for x right there. So instead of x plus 5y, let's put what x is. X is really also 5y minus 16. Now, plus 5y equals 4. Combine your like terms. Add 16 to both sides. Divide both sides by 10. Y equals 2. Now that we know what y is, we can solve for x. Let's use the bottom system here. X equals, instead of 5 times y, well, y is 2. 5 times 2 is 10. And minus 16 is -6. And now we know what our one solution is to this system of equations. Our one solution is -6, comma 2. And now example 5, they want us to graph these systems of equations and figure out what the solution is. So let's graph this top one here. Start with the y-intercept at +4. 1, 2, 3, 4. Your slope is -1. So down 1, right, down, right, down, right. And if you were to continue that pattern over here, it would look like this. All right. Now you should connect those, but I'm not going to. Y equals x minus 6. Start with the y-intercept at -6. 1, 2, down 6. There we are. Your slope is 1, so up 1, right, 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 right 1, up 1, right 1, up 1. I'm going to go ahead and stop because my solution to this system of equations is that coordinate that I just boxed right here. That's where those two lines would meet. Let's figure out what is that ordered pair. Looks like we'd have to go right 1, 2, 3, 4, 5 units and down 1 unit to get to that ordered pair where they meet. So our solution is 5 comma -1. Now they actually want you to use your calculator here, and I'm going to show you some tricks here. Let's start by graphing the line y equals 2x plus 3 in our calculator. Go to y equals 2x plus 3, and then we're going to graph it. Okay, what do they want us to do here? Let's see. Label the y-intercept and x-intercept with ordered pairs. Find the indicated value using the trace screen. So this particular these features that I'm about to show you now, it comes in handy whenever your x-intercepts or your y-intercepts are not perfect ordered pairs. Or maybe if your y-intercept or your x-intercepts aren't even visible on the screen. Now, these first few examples don't necessarily qualify for that, but we're going to use them to show you how you solve them using your graphing calculator. If you want to solve for your y-intercept, here's what you can do. Second, trace, and then just hit enter. We want x to be 0, and then push enter. That's your y-intercept. Anytime x is 0, that tells you what your y-intercept is. So our y-intercept is 0, 3. What about our x-intercept? Now listen, there's a couple of ways of doing what I'm about to show you. This is just the manner that I happen to prefer. Let's start with, let me tell you about our grid here. We have a x, y coordinate plane. Now the x values that we can see on our screen are from -10 to +10. And the y values that we can see on our screen are from -10 to +10. In order to use the feature that I'm about to show you, at least the method I'm about to show you, you just have to have a level of awareness of, well, where is your x-intercept? And what numbers does that fall between? X values, at least. Well, we know that the x-intercept is somewhere in between -10 and 0. This is where x is -10, this is where x is 0. Our x-intercept is somewhere in between them. Keep that in mind. It's in between -10 and 0. So let's hit second trace. Now this time you want to select 0. We are finding the x-intercept, which is also known as finding a 0. When it says left bound, you want to tell it -10 and then push enter. When it says right bound, you want to tell it 0 and then enter. And then when it says guess, you just want to hit enter one more time. Anytime y is 0, you know what your x-intercept is. Our x-intercept is -1.5. Okay, let's do another one. Example 2. Go to y equals, clear out that previous data, and let's enter in this new function, -x -1, and then graph it. How about we start with solving for our y-intercept? Second trace, and then just push enter. We're solving for the y-intercept here. When you see this, just make x equal to 0, and then push enter. Our y-intercept is -1. All right, now let's find the x-intercept. Here's where the x-intercept is, right there. Once again, it is somewhere in between -10 and 0. Second trace, select this option. When it says left bound, tell it -10, enter. When it says right bound, tell it 0, enter. And when it says guess, just push enter one more time. Our x-intercept is -1. Okay, example 3. Let's go to y equals, clear out your previous data, and let's enter in x plus 12. Graph it. Okay, let's find the y-intercept first. Even though we can't see it, that's okay. Second trace, push enter, push 0, enter. Our y-intercept is 12. Now, the x-intercept. We can't see it, so we're going to have to adjust our screen. Here's what you're going to do. Well, first of all, our x-intercept, let's just pretend like this were to continue. It's probably right about here. All right. Well, my screen only goes to where x is -10. If we could increase it to where x is -20, I bet we could see the x-intercept. So let's do that. You're going to hit Window. Now, it's currently right where we need it, x minimum. It's saying the minimum amount of x's that you're going to be able to see on your screen is -10. Let's change it to -20. And now graph. Now we can see it. We now know that our x-intercept is somewhere in between -20 and 0. So that's what we want to use as our new left bound, right bound. Second trace. Select that option. When it says left bound, you're going to push -20. And when it says right bound, you're going to push 0. And when it says guess, push in. Our x-intercept is -12. Okay, move on to the last side of our notes. Okay, I'm only going to do examples 1 and 2 here for you. They want us to graph two systems and see where they meet using your graphing calculator. Before I do that, I'm going to take my screen back to the factory default setting. If you'll push zoom and then the number 6, that takes you back to the normal grid where x is -10 to +10 and y is -10 to +10. Go ahead and push y equals. Clear out the previous data, and now let's enter that first system there where it says y1. Scroll down, and now enter the other system, -x plus 4. Let's graph. All right, we can tell by looking at our screen that they meet right there, but we don't want to guess. So here's what you're going to do. Hit second, trace. You're going to select this option, intersect. Where do they intersect? Push enter. All right, you see this little, looks kind of like a spider on my screen. Calling up spider webs. Leave a message and I'll call you back. If you know what that's from, send me an email. Okay. Here's what you want to do. You want to take that spider and get as close to that point of intersection as you possibly can. It looks like right about there. Looks like that's about as close as I can get. And then just hit enter once, hit enter twice, hit enter 3 times. That's where they meet. And I think it tells us to round to the nearest 100th if needed. So let's round that to 0.33, comma 3.67. That's how you do them. And we're going to stop there because, as I mentioned, I don't have that much time. Practice more if you want.